All right, it's working. So this is a question paper that I gave you guys yesterday, and I was hoping to have received submissions for this so that I can see how people are performing, including how long it takes people to solve a question. All right, so you're given these following numbers: 7 root 2, 0.4, 3 recurring, the square root of negative 121, pi squared, the cube root of negative 1 over 27. From this, you're supposed to to write down two rational numbers. So rational numbers, remember, I think we use the symbol Q for those rational numbers. And then we say these are numbers that we can write as A over B, where B is not equals to 0 like that. So that will count as our rational number. So a number that we can write as a fraction. So rational numbers, they do include our integers. They do include whole numbers. They do include natural numbers. They do include decimals. But these decimals have to be terminating. They have to be terminating decimals. So it has to be a number like 0.54, like that, not something that doesn't end, not a recurring decimal or decimal that doesn't end. So from that, we have to just take two of these over here and see which one counts as a rational number. Right. So if we check this number over here, which is the cube root of negative 1 over 27, this will just give you negative 1 over, I think this is 3. So this, if you check this, you manage to write it as a fraction like that. So this will count as a rational number. Right, let's look at another one. This is also a rational number. So that's 0.43 recurring like that. So we can say that's a rational number because we are able to represent this as a fraction. So there's a question for that one over here. You're able to represent this as a fraction. Right. So those are the two solutions they were looking for. So this is not a rational number. So if you're going to plug in 7 root 2 on your calculator, you have a very, very long decimal. This one will give you undefined, so it's a non-real number. And this one, pi, is non-terminating, 3.14 what. But already here it's being squared, so it will be 9 or 10 point something, but it's non-terminating. So the only numbers that count as rational numbers are the ones that we are able to write them as a fraction like that. And we're saying those are integers, whole numbers, natural numbers, and decimals that are terminating, or we can say, we can also add recurring decimals. So recurring because we are able to write these as a fraction. Any questions there? So this work was covered, I think, earlier in the year, January, February type of thing. All right. Next, for 1.2, they're asking you to write down the value of pi squared, round off to 2 decimal places. So I'm expecting people to know how to find the pi symbol in a calculator and then square it and then give the answer there. That's for 1 mark. So supposed to round that off to 2 decimal places. So is anyone with a calculator nearby? What's pi squared?
9.87.
9.87. What were the other numbers? Before rounding off, it was what?
9.87. 869604401.
All right, something like that. So if they're gonna say to round off to 2 decimal places, they're saying that after the comma, I'm only looking for 2 numbers. So if you're gonna, if you're only gonna have 2 numbers after the comma, you look at the third number only. You don't care what was here. Just look at the third number and check, is it from 5 up to 9? If it is, you add 1 to this number. So 9 is in this range, so you just add 1 to this one. So this ends up being 9.87, like that. But if this was 0 to 4 with 4 included, then this would just be 9.86 only. Does that make sense?
Yes.
I'm hoping everyone is able to round off. All right, next question is asking us to write this recurring decimal as a fraction. So you're given 0.43 recurring, like that. So this is just saying you're having 0.433333 and so on, like that. So what you will do, you will say let this to be x, like that, right? And then from there, you check how many numbers were after the comma, or how many numbers are important there. It's just 4 and 3. The other 3s are repeating themselves. So in order to just have this 43 this side, that means I can just multiply this by is it 100?
Yes.
100, right? Not 10, yeah, 100. So you multiply, so you say x times 100 over there. So this ends up being 100x, it's equals to 43.33333 and so on. So these 3's are recurring, like that. So what you will do now, you'll say this is your equation 1, this is your equation 2. You say equation 2 minus equation 1, like that. So this ends up being 100 minus x, 100x minus x, you end up with 99x. It's equals to, and then you have this number over here subtracting that. So it will be the same thing as saying 43. There's a 0 here, and then you have all of those 3's that are recurring. So all of these 3's recurring will cancel out each other. So you'll end up with 43 minus 0, which is 43. So this is supposed to give you your answer, like that. Can we check if that is giving us
It's 0.43.
just 0.43?
0.43.
So it's repeating 43.
Yes.
All right, that's not what we want. We only want it to repeat 3, not 4. Right, so we need to adjust our calculation here. Let's adjust it. So the only number that's repeating in our case is 3. So that means we just need to multiply that by 10 instead of 100.
Exactly.
Let's try that one. So it's 4, 3 recurring. So this will be 10x. It's equals to 4.3 recurring, like that. Does it make sense why we changed our calculation?
Yes.
All right. So this will end up with still doing the same thing, equation 1, equation 2. This ends up being 9x. This ends up just being 4. Divide by 9, divide by 9. End up with x, it's equals to, what does this one give us? If it's 4 over 9 like that, what does it give us?
0.9. 0.44444.
Still wrong.
Second, bengabe 43 over 9.
43 over 9.
I mean 4,3/9.
Okay, let's try that, but doesn't make, because we multiplied here by 10.
Yeah, Lasse.
Yeah, all right, that's fine. I'll look into it. We're just supposed to multiply by 10 here, so there's something off there. But okay, so this is how you'd handle the question, right? I'll look into this and then I'll write a solution for you guys. All right, for 1.4, we are asked to find out between which consecutive integers does 7√2 lie. So we are looking for 7√2. So that means we'll do that thing of finding the perfect square that will be before this number and the perfect square that will be might be above this number, right? So if we were to guess square root 2, it's 1.4 something, right? If you're gonna punch in just square root 2 on your calculator.
It's 9,899.
Yeah, just square root 2 on its own, not with the 7.
1,41. Yeah, 4213. 4142.
Right. All right. So that means if we were just looking at square root, if we're just dealing with square root 2, the number that we would say is the integers that this 142 would be between would be 1 as a perfect square, as well as, what's the other one? 4 as a perfect square. Do we agree?
Yes.
All right. So these would be the numbers that this would be between. So I think we need, let's apply square roots here and see. So this will just be, so this would be for square root, for root 2. If we have square root, let's do this. So just for square root 2, let's estimate square root 2 alone. This gives us 2 like that. Everyone happy here? This number is between 1 and 2. Those are the integers. But now if we are having square root 2, that means they multiplied this by 7. So they multiplied here by 7. So that means the only thing you need to do is multiply by 7. Let's see. So this won't work. If we multiply by 7, what's 4 times 7? We don't get the square root of that one. We just need to multiply this by 7.
It's 28.
So we don't have a square root of 20. Yeah, we don't have the square root of 28. So that's another issue. So this, we said this 7√2 was 9 point what? We said it was 9 point?
9.89949.
All right. So there's no way we are getting 7 and this being 14. These are not consecutive numbers. So this is supposed to give us this being 8 and it's going to be 8 and what? 8 and 9, right? No, it's 9 and 10. Sorry. 9 and 10. So those are supposed to be our values. So let's see how we can get these values from the word go here. All right. So if it was square root 2, it's fine like this. But now there's a 7 over here. That changes things a bit. I thought we we're just going to multiply it by 7 over here. All right, so I think you can just plug this into a calculator and get that 9 point what. and then plug your 9 and your 10 this side, and that's about it. I'm trying to think of a way that this might be done properly. All right, your integers there are just 9 and 10. As long as it's one after the other, because they're saying consecutive like that. Any questions on your question 1? Did we attempt these questions? Did we attempt?
Sir, I wonder the way when 1.4 ne. Nazangize. Mangize example ne. 2 square root 6. Mawumphatha ku calculator ngithi ukhipha 4,898979,486. Then from lapho angithi so yase uthi inumber shukuthi ila between 4 no 5. So ufune square root se esizokunika u4 angisho. Then which is u16. Then in between ufaka u2 square root 6 wet. Then mawufuna square root esizokunika u5 which is u25. Say so the answer la u4, then in between u2 square root 6, then u5.
Yeah, but that's not giving you the number that you it's in between is no longer this number. Remember, we are looking for where does this belong?
Yeah, so my answer ngisho I told ila between 4 and 5.
Yeah, but we are looking at 9 and 10 over here on our side.
Oh, okay.
All right, so that means we're looking at the square root of 100. We're looking at the square root of 81 somewhere there. We just need a way to formalize it.
Okay, so.
All right. So for your question 2, you were asked to find, to expand here and get the product. So expanding, remember, we're just saying this has to multiply that, 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 and so on and so on. So the quickest way to do that, we can just say 2a has to multiply that bracket. Like that. And then minus 3b has to multiply that bracket as well. Right, so this gives us 6a cubed. This gives us 4a squared b minus 6ab squared. So we are done with that one. And then this is minus 9, it's minus 9a squared b. This is minus 9a squared b. And then this is minus 6ab squared. And then this is plus 9b cubed, like that. Next, we look at our like terms. So this has a squared b, this has a squared b, so that one and that one count as like terms. This has ab squared, this has ab squared, so this guy and that guy count as like terms as well. All right. So that means this doesn't have a like term, so we'll write it as it is, 6a cubed. This and that are like terms, so we are supposed to say this is plus 4 minus 9, so that's going to give us minus 5, a squared b, like that. And then this is minus 6ab squared and minus 6ab squared is going to give us minus 12ab squared. This doesn't have any like terms, so we write it as it is, like that. So we don't have any like terms anymore, and then that means this becomes our final answer. Any question on that one?
No.
All right. Next, we were asked to factorize fully. So if we're asked to factorize fully, they're not going to tell us which method to use. So we have to go through our methods. So we are given 3x plus 6y minus ax minus 2ay, like that. So remember, the moment you're given something that has like 4 terms, the method you're likely to use is grouping, like that. So remember, grouping, you're gonna group 2 things that are likely to give you something that will be common that you can take out as your common factor. So here, if I'm gonna group these like this, you group it with its sign. Here, the common factor for me will be 3. So if I take out 3, I'm left with x plus 2y. Here, I can take out negative a, like that. I'm left with x plus 2y. Right, so I've taken out the common factor. Next, remember, for grouping, you take out the common factor 2 times. So this is one term, this is another term. So on this term and that term, you look for something similar. This bracket and that bracket are the same. So you take them out as your common factor. You're left with this. And then there's nothing more that you can do there. We are done. Any question on that one? Any question on grouping?
No, sir.
All right. 2.2.2, you're given 3x squared plus 17x minus 6. So you have 3 terms, so it's most likely to be a trinomial, right? So firstly, remember a trinomial, you are looking for factors of this term and factors of that term such that when you add or subtract them, they give you this term. So when you add or subtract them, they're supposed to give you that term, right? So one method that I've done with you guys was this one. We get the factors of 3, which is factors of 3 will be 3 and 1. Those are the only factors of 3. For factors of 6, it would be 6 and 1. It will be 3 and 2, like that. Do we have another one? Do we have another one?
No.
All right. So what we're gonna try and do, we're gonna try and multiply our factors got 3, number factors got 6, so that we see how are we supposed to place things in the brackets, right? So if I'll multiply these like this, I'm gonna get what number? 3 times 8, 3 times 6.
18.
18, and then that means if I multiply these, I'm just gonna get 1. Right, let's see a different combination. So it's 3 times 1 for 3. The other one would be using 3 times 2. So if I'm gonna multiply these like this, I'm gonna get 9. If I'm gonna multiply these, I'm gonna get 3. Let's try it. It's not 3, it's 2. This has to be 2. So multiplying this gives me 9. Multiplying these gives me 2. Right. So let's see another combination. So I could have also multiplied like this. I could have multiplied 3 and 1. The other one could have been 2 and 3, like that. This is going to give me 6. This is going to give me 3, like that. Another combination we could have done, we could have had 3 times 1, 1 times 6, like that. So these ones will give me 3. These ones will give me 6. Can we see the different combinations or different multiplications that we can do here? Right. So now if we will take what the numbers that we got. Here we got 18 and 1. Here we got 9 and 2. Here we got 6 and 3. Here we got 3 and 6, which is just 6 and 3, like that. So let's see which ones, if we add or subtract them, will give us 17. So if we add, if we subtract, if we are adding, we get 19. We subtract, we get 17. Add, we get 11. Subtract, we get 7. Add, we get, is it 9? Subtract, we get 3. We add, we get 9. Subtract, we get 3. So this one and that one are still the same thing, right? So which one are we supposed to use? Remember, we are looking for 17. So which one gave us 17?
18 and 1.
18 and 1. So we're going to check. This was the combination that gave us 18. So this is how we're going to write it in our brackets. So we'll say, open two brackets, and then we say, I have to multiply 3 and 6. So I have to have 3x here. For the only way I can get this 3x to be multiplied by 6 is if the 6 is this side. Right. Next, I have to have 1 and x. So if we check, multiplying this will give me 18x. This will give me 1x, like that. And then if I add or subtract, that's when I'll get that 17. But if we were using a different combination, if maybe we had the 6 over here, that means this would be 1. So this would be 3 times 1. I'll only get 3x. This will be 6 times x. This will just give me 6x. This will give me this guy over here. Can you see that?
Yes.
All right. So in terms of placing our guys, this is how we're going to have it. Next, the signs. This one is a minus. It's telling us that we have different signs. This is a plus. So the plus over here, or the sign of the middle term, will be the sign of the bigger number. So we get the bigger number by saying 3 times 6. So that means this will be plus, this will be minus, like that. And we have factorized it like that. That's all we were supposed to do. So answer has to be 3x minus 1 and x plus 6, like that. All right. 2.3, we are asked to simplify that. So we're given 2 exponent 3 n plus 2 times 8 exponent n minus 3 over 4 exponent 3 n minus 2. Right, so the first thing that you will try to do, you change all these numbers to be prime bases. So remember, a prime number is the one that has only 2 factors, 1 and itself. So you have to change this to its prime factors. So I think I showed you a way on your calculator to get factors of these numbers. So for 8, remember, you just say 8 equals to, if you're using a Casio, just say 8 equals to, and then you'll get 8, and then from there it will be shift, and then you look for a pattern that has fact above. What do you get?
2 square root 3.
3.
2 exponent 3 or 2 square root 3? Which one?
Exponent 3.
2 exponent 3. So this is what you have, like that, right? So that means you'll rewrite this 8 as that. And then if you do for 4, what do you get?
Two exponent 2.
All right. So that means this is just going to be 2, 3n plus 2 times. Now we are no longer writing 8, but we're writing 8 as 2 exponent 3, n minus 3 out there, over this. You said it was 2 exponent 2. This is still 4. And then you have that 3n minus 2, like that. Right. Then from here, we just have to remember our laws of exponents. So remember, this is saying that I had 2 bases that were the same, that were multiplied, like that. So 2 bases were the same. So when we multiplied them, we added the exponents. So this ends up being 3n plus 2. So this is what we have. So that means we can rewrite this as that. Right. Another law that we need to remember is the one whereby we're having an exponent raised to another exponent. That's exponent raised to another exponent, we multiply the exponents like that. All right, let's see. So that means here we're just having 2 exponent 3n plus 2. This, okay, we'll come back to this. This ends up being 2 exponent 3n minus 9 like that. We have multiplied this 3 with everything that's outside there. This is what we have. Divided by, this will be 2 exponent 6n minus 4. Everyone happy here?
Yes.
All right. So from here, we apply that first law. We can break this thing down. So we are having 2 exponent 3n, 2 exponent 2, 2 exponent 3n, 2 exponent negative 9 over 2 exponent 6n, 2 exponent negative 4. So what we do from here, we don't cancel bases or something like that. What we will do, we'll just keep a single base and then collect all the exponents that have n according to the laws of exponents. So this one and that one are being multiplied together. So it will be 3n plus 3n. They are being multiplied together. So we add them. This one is being divided by. So if we divide, remember, we subtract that exponent. So this is what we have. Does this one make sense? All good?
Please repeat.
All right, so we are saying I'm gonna keep one base. This is the base I've kept, which is 2 over here. And then I'm gonna group together the exponents that have variables. But how am I gonna group them? I'm gonna group them according to the laws of exponents. So this and that are just being multiplied together. So to get an answer here, I'm just gonna have to add the 2. So I'm just gonna have 3n plus 3n like that. This one, on the other hand, we are dividing by it. So if we are dividing by something, remember it will be the top exponent minus the bottom exponent. That's what we are having here. This is everything on the top minus the bottom exponent for the ones with the n.
And
You are good now?
yes, sir. Thank you.
All right. And then from there, we take another base of 2 and we keep all the other things without the n variable. So that would be, let's get a different color here, like that. So here, 2 plus negative 9 over here, because those two are being multiplied, minus, we are minusing this thing at the bottom. So we do it like that. So we have taken into account all the exponents. Every exponent has been accounted for. From here, these are now like terms. You're having 2 exponent 3 plus 3, you get 6, minus 6, you get 0. So this is 0n now. So this is just 0 like that. Times, here you're having 2 minus 9 plus 4. What do we get there?
Negative 3.
Negative?
3.
Negative 3. So write that as negative 3. This is just 1, then 2 times negative 3. So whenever they're asking you to simplify, they'll want you to leave your answer with a positive exponent. So you'll remember there's a law that says if I have a negative exponent like that, this is just becomes this, like that. So that means this will just be 1 over 2 exponent 3. But we know what 2 exponent 3 is, right? This is the answer, like that. Any questions?
No.
No.
Right, you can check this answer before even submitting your script. So go back to the original question. So you can choose a number there. So whenever you're seeing n, you can plug in that same number. So let's try it. So we can use 1 maybe, or 10, doesn't matter. So it's 2 exponent 1 over here plus 2, 8, 1 minus 3 over 4, 3 into 1 minus 2. Right, so you punch all of this into your calculator and see if you're getting the final answer that we got. If we don't, that means we did something wrong. What are we getting?
So we still
Sorry?
say each 1 over 16.
1 over 16. Are we all?
Yes.
Oh, okay. This is supposed to be 3, not 2, sorry. Yeah. Supposed to be 3.
One over 8.
1 over 8.
Yeah, right. So, okay, my bad. So yeah, 1 over 8, which is the answer that we have here as our final answer. Right. So that's how you would check if your question, if your calculation is correct. Right. The last part over here, let's move on to a different page. Last part, still asking us to simplify. So we are given 2 fractions like that. Supposed to simplify. So I have p exponent 3 plus p exponent q exponent 3 over p 6 like this times 3p minus 3q over p squared minus q squared. Right. So when you're simplifying fractions, what you need to remember is that you factorize the numerator of this one on its own. You factorize the denominator here, factorize like that. So what method of factorization are we going to use here? Or what type of factorization is here? I'm having 2 cubes. What is this? Two cubes and a plus. What is that? All right, sum of 2 cubes. Right, so that's a cube, that's a cube. So we're having plus, so it's the sum of 2 cubes. Here, there's nothing I can do. You can leave it like this. And then if we move on this side, here I can take out common factor. Here, it's difference of 2 squares. Like that. So here, sum of 2 cubes, remember, small bracket and a bigger bracket. So small bracket, you just have it like this. Bigger bracket, you have that. You have this times that, PQ, you have this squared. And then signs, if you add a plus, to be plus, minus, plus. If you add a minus, it's going to be minus, plus, plus. So all the time you end up having 2 positive signs. Right. So this was just the numerator over there. This 6p squared, you write it as it is. Over here, times common factor, it's 3, p minus q, like that, over this difference of 2 squares, p minus q, p plus q. Right. So we have factorized everything now. We no longer have terms that are loose. So this is just one term right now, because everything is attached by a multiplication sign. So now that means we can start canceling things out. We only start canceling things out if we no longer have multiple terms, just one term. So this cancels that out. This cancels this out. The 3 over here like that. So what we are left with, it's just p squared minus pq plus q squared over 2p squared, like this. So this, it's 3 terms. We cannot do this. We cannot say this goes out with that, because this is now 3 terms. Why am I saying this is 3 terms? This is p squared over 2p minus p q over 2p squared, like that, plus q squared over 2p squared. So this is term 1, term 2, term 3, like that. Does that one make sense? So this ends up being your final answer. So this ends up being your final answer. There's no more factorization that you can do. Over here, we are done. All right. Okay, we still have time. So this was question 2. Let's see if we can tackle another question. All right, question 3 of that question paper from yesterday. You are asked to solve for x. So remember, solving for x, we are most likely to, if there's factorization involved, you factorize. You make sure that your variables are on one side, the other things are on the other side, and then you just solve for x. So for the first one, we're having 3x minus 5 is equals to 2 into 3x minus 1, like that. So this we can multiply by the 2 inside. So I have 3x minus 5 equals to 6x minus 2. Then I can gather everything with the variable to one side. So I have 3x minus 6x is equals to minus 2 plus 5. This gives me minus 3x. This gives me 3. I divide by minus 3. I divide by minus 3. I end up getting my x value is negative 1. Right. So remember to check if my answer is correct. I go back to my original question. So I plug this in. So I get minus 3 minus 5. This gives me minus 8. So this is my left-hand side. Let's see what the right gives me. So it's going to be 2 into 3 into minus 1, like that. So this gives me minus 3 minus 1. This gives me minus 4. This gives me minus 8. So my left-hand side is equal to my right-hand side. That means my value for x is correct. Any questions on that one? So you do your calculation, you get your answer, you check on your calculator if the left is equal to the right, and then you scored yourself nice 3 marks there. Next one. Yeah, so asking us to solve for x as well. So it's x minus 2 here equals to 8. Right. So if this was 0, you could have just said x equals to 0 or x minus 2 equals to 0, but it's equals to 8. You cannot say this is equals to 8 or that is equals to 8. That means you first need to bring it this side, break the brackets, and try to refactorize again. So this is x squared minus 2x minus 8 equals to 0. This is a trinomial. Factorize it. So it's x, it's 4, it's 2, it's minus, it's plus, like that. So now this is equals to 0. You can say this bracket will give me 0, or that bracket will give me 0. So it's x minus 4 equals to 0, or x plus 2 equals to 0. So this is x equals to 4, or x equals to negative 2, like that. Right. Again, you check, is my answer correct? So that means I'll have, for the left-hand side, I'll have 4 times 4 minus 2, like that. This will give me 4. This will give me 2, so 4 times 2 gives me 8. So that means this value is correct. Let's check the other value. So I'll have minus 2 into -2 minus 2, like that. So this gives me -2, this gives me -4, this gives me +8, like that. So that means also this value is correct. Any questions on that one?
Nah.
No.
All right. Last question over here, we are given 3 exponents 2x plus 2 is equals to 1 over 27, like that. Right. So the trick here is to turn this to have a base of 3. Right. So to do that, you can change 27 to be to its prime numbers, which will give you 3 exponent 3. And then here you can remember that if you are given this, you end up with that. So we are just reversing this. So that means we are given 1 over 3 exponent 3. We are now reversing it. This will now be 3 exponent -3, like that. So this is what we did here. We are doing here. So it's 3, 2x plus 2 is equals to 3 exponent -3, like that. So now we are having the same basis. We can equate the exponents. Therefore, 2x plus 2 equals to -3, and then we can solve for x nicely. So this will be 2x equals to -3 minus 2, and then 2x is equals to -5. And then divide by 2, you divide by 2, your x is equals to -5 over 2, like that. So that's our answer. Again, we try to check if this is correct. So we go back to our original question. So I'll have 3 exponent 2 into -5 over 2 plus 2, like that. Let's see what that gives us. Does that give us a 1 over 27? Can we check? So where we are seeing x, we plug in that. So this will give me -5 plus 2. This will give me that. And then this is just 1 over 27, like that. Do we get 1 over 27?
Yes.
All right, wonderful.
Yes.
Okay. Let me see. What else? Oh, there's still more question 3. Okay, let's see if we can solve this. Do we still have time though? I'm trying to cover as much as possible of that question paper. All right, so 3.2 is an inequality. You are asked to solve that and represent it graphically, right? So it means they're expecting something, whether it's a number line or something along those lines, or you're gonna draw it using a parabola or what, but they're expecting it to be represented graphically. So it's -1 over 3, it's less than x minus 1 over 6, less than 1 over 18. Right. So remember, I always say if this was just 1 over 3 equals to x minus 1 over 6. To get rid of this 6, you just multiply by 6 both sides. So that's what we're going to do here. So I'm going to multiply by 6 here. I'm going to multiply by 6 there. I'm going to multiply by 6 here. So since we have 2 signs of inequalities, what I'm going to do on this side, I also do this side. So I end up here having -6 over 3. This is x minus 1. This is now 6 over 18. This is going to give me -2 x minus 1. This is just going to give me 1 over 3, I think. Okay. Then from there, we need to get rid of this 1. If it was a normal equation like that, I'll just transpose this to the other side. So I'll have -2 plus 1 equals to x like that. So I'll transpose this to the other side. So this ends up being -1 less than x less than, what does this give us? 4/3, I think, like that. So after doing that, we have solved the inequality. To represent this graphically, this is what you would do. So you write down those numbers like that. And then this value, these values are in between. Let's see, what are we doing with here? So it's just gonna be like that. This is us representing the numbers graphically. So we are saying that the x value has to be greater. So from here, going that side, the numbers are greater than -1, but it has to be less than 4/3. From here, going that side, less than 4/3. Hence, we have this line joining like that. Any questions on that one? All right. Next question, I think it's a word problem. So we're supposed to take that statement and make it to be an equation. Right, so we are told that a fruit yogurt costs 4 rand more than a plain yogurt. It is further given that 5 fruit yogurts and 3 plain yogurts together cost 84 rand. So here we are told to assign x to the variable to be the price of the fruit yogurt and y to be the price of the plain yogurt to set up a system of equations. So this is a simultaneous equation. So let's check. Here we are told that, what's this? A fruit yogurt costs 4 rand more than plain yogurt. So if we are saying that fruit yogurt is x and plain is y. So we can, the first equation we can have is that fruit yogurt costs 4 rand more than plain yogurt. So fruit yogurt costs 4 rand more than plain yogurt. Do we understand this part?
Yes.
All right. So from whatever price you have on plain yogurt, you add 4 rand. So that's the 4 rand more part, like that. So this is our first equation. Second equation, we are told that if we're gonna take 5 fruit yogurts and 3 plain yogurts together, we're gonna get that to be 84 rand. So if I'm gonna take 5 fruit yogurts and 3 plain yogurts together, I'm gonna get 84 rand like that. That's my second equation. Right, so this was the 2 marks over here. So the question could have just went from this to that for 7 marks without giving you a clue to this step. So this could have just been one statement for 7 marks. So they were generous here to tell you what to do in terms of making fruit to be X, making plain yogurt to be Y. So you have set up your system of equations. Now they're asking you to use these equations to find the individual prices of the yogurts. Right. So this is a simultaneous equation. You can use any method you want, whether it's substitution or elimination. I'm going to use substitution quickly here. So sub equation 1 into equation 2. So I have 5 into y plus 4 plus 3y equals to 84. This will give me 5y plus 20 plus 3y equals to 84. This will give me 8y equals to 84 minus 20. 8y equals to 64. And then I divide by 8 both sides. This will be y, it's equals to 8. Right. And then from here I can sub y into equation 1. So I'll end up with x equals to y plus 4, x equals to 8 plus 4, and then that means my x is equals to 12. So that means fruit yogurt, it's gonna be 12 rand. Plain yogurt, it's gonna be 8 rand, like that. Any questions on that one? Any questions on that one?
No, sir.
All right, we have question 5 and question 6. Should we run through them and then I get you another question paper that you guys can do on your own?
Yes, so we can run through them.
All right. You guys will watch the recording then if you won't have electricity after this.
Yeah, it's from maybe after an hour, yeah. Because this will have my magic 8.
Okay. That's fine. Let me just try and do this quickly then. So it's functions, that question, and I doubt that you guys did functions a lot at your schools, but it's fine. All right, so here we are given f at x and g at x. So f at x, they've represented there, it's the parabola. G at x is the straight line over there. Right, so you're given that equation, f at x, it's equals to negative x squared plus 9. G at x, it's equals to x minus 3, like that. Firstly, we are asked to calculate the coordinates of C and E. So C over here and E over here, which are the y-intercepts of the graphs. So y-intercept, remember, you let the x value to be 0. So we can say y-intercept at x to be equal to 0. So for f over here, you'll end up with negative x squared plus 9, like that. So this will just be 9, like that. So that means the coordinate for C will be 0 and 9. The other one just gonna be like this. Wherever you're gonna see x, you plug in 0. So it's just gonna be negative 3. So that means the coordinate for E is 0 and negative 3. Right. So if they're asking you for coordinates, like the full coordinates, you have to give them the x value and the y value. If you leave it like this, you might lose some marks for not giving them the full answer like that. All right. Any questions on that one? Intercepts? Questions?
No, sir.
All right. Next, we are asked to calculate the length of CE. So here we have determined that this is at 9, this is at minus 3. So the length from there to there is just a straight line, just have to count. So there's minus 2 here, there's minus 1, there's 0, there's 1, 2, 3, and so on up until 9. So just counting the distance from there to there. We're supposed to get, I think it's going to be 12 units. Do we agree? You count 3 units, 1, 1, 2, 3. You add 0, you add the 9 over here. So it's 3 plus 9, you get 12. All good?
Yes, sir.
All right. Next, we are asked to find the coordinates of A. A is over here, which is the points, the point of intersection of the two graphs. Right, so they are not asking us to find this one, but that one. So point of intersection, remember, both have the same y coordinate, they have the same x coordinate. So point of intersection, you just say f at x is equals to g at x. F at x is minus x squared plus 9 equals to x minus 3, like that. And then this is just minus 9x minus x squared plus 9 minus x plus 3 equals to 0. We try and factorize this guy. This would be minus 12 equals to 0. This is a trinomial. x and x, 3 and 4, plus minus. So our x values, it's equals to 3, or our x values is equals to minus 4. Right. So if we will check, it's this guy, A is on the negative x values. So x values that are negative. So it cannot be this guy, but it has to be minus 4. So that means we're going to be using minus 4. We only have the x value. We are looking for the full coordinate. We just need to substitute this back into G or, what's the other one? G or F. So we can say sub x equals to negative 4 into G. So we'll have G at minus 4 like that, being minus 4 minus 3 like that. So that means this is going to be minus 7. So that means the coordinate of A is minus 4 and minus 7. Any questions regarding that one?
No, sir.
Okay. Next, we are asked to draw a sketch of that graph, which is y equals to abx plus q, where a is positive, b is greater than 1, and q is less than 0. So that means it's an exponential graph. You just have to remember the shape of your exponential graph. So if your a value is positive, we're expecting it to be on the top, somewhere here. That's the first part. And then your b value is greater than 1. That means it's facing where? Where is it facing? This way or that way? Let me just get graphing calculator. And I'm just gonna have a fast drawing here. So our a value is positive, so we're gonna give them 1, which is positive. Our b value is greater than 1, so let's give them 2. And then exponent x. And then they said our q value has to be less than 0, so it has to be a negative, so negative 3 maybe, like that. So that means the graph that we're supposed to draw, it's just something like that. So it's just gonna be something like that. And then here you'd have your asymptote with the q value like that, and then that's about it. That's all you had to do for that 3 marks over there. Any questions? Questions? Okay, there's a very, very loud silence now. Okay, I'll assume there are no questions. And I'll assume I'm still talking to people. Right, the last question on that question paper is this one. So it's for 6 marks. We're given a hyperbola like that, which is h at x. So it's h at x, it's equals to 2 over x minus 1. Supposed to find the x-intercepts of h. So x-intercept, you let y to be 0. So x-intercept, let y to be 0. So to be 0, it's equals to 2 over x minus 1. So this would be 1 equals to 2 over x. You multiply by x both sides. So you end up with x, it's equals to 2. So that means the x-intercept of h is going to be 2 and 0. And that's the only one you have. Right, any questions? Hello? All right. Next, we're supposed to write down the equation of the horizontal asymptote of h. So asymptote, remember, it's the line that we approach but never touch. The horizontal asymptote, it's the one that's placed horizontally. So we are looking for this line. Remember, I said it was just the q value. So that means it's just going to be y, it's equals to -1. That's the equation of the horizontal asymptote. Next, you're just supposed to draw this graph. I'll leave that one up to you. Any questions? That's the whole question paper.
No, sir.
No? All right. I'm gonna send you guys another question paper on the group, and people please write something and then send it to me privately so that I can see that you are actually working.
Yes, sir.
All right. If there are no other questions, I'm out. All right, bye.